Assalamu alaikum. My name is Umar and today my topic of presentation is Markov decision process. So let's start. So before discuss what is Markov decision process, I have a question for you guys. The question is, how would you go to Lahore on Friday night in the least amount of time? So let's assume there is some event happening in Lahore and you have to reach there in just least amount of time. So how would you manage your transport? I have a couple of options for you guys. How many of you guys gonna use bike? Raise your hands. And how many of you go through car or something? And how many of you gonna use train? And the next option is Uber or Cream and through aeroplane. So the purpose of question is having my question purpose of this that it's not just necessarily search problem where you just choose one option and go through with that. Like in real world there are a lot of uncertainties. There are a lot of things happening in background where you don't think about that and they are actually affecting your decision. What if you choose bike, you can get a flat tire, a puncture, and you have to keep them in your account while decision. And also in bike, the long distance is not comfortable. So also there's a lot of problems with drive or car. If you go with car, you may get stuck in traffic, and you have to reach there in least amount of time, and you waste your time in traffic. So it's also a problem, and you have to notice about that. And if you go with train, there are also all sort of delays in train. So you have to keep them in your notice while making decisions. So it's not just a pure side problem. You just choose one option and go through that. So in real life, there are a lot of uncertainties happening which lead us to Markov decision process.
So I first of all I would like to appreciate Umar about the realistic approaches to move from Islamabad to Lahore for attending certain events. Of course, if I do not have enough money, then I will choose a bike. Of course, this is the least possible option for me, but it is a complicated and complex and difficult one. But I hope we would like to listen from Umar further about the Markov decision model, and I am really impressed by his start. Clapping for him.
So one state is deterministic. So in deterministic, you are sure about your upcoming state. What if you you know that if I take this action, I will gonna reach to that state. That is the deterministic, where you have a state and you take action and you go to your desired state. It's a deterministic. So if you look at graph up there, if for example if you are on the state of S and you want to reach to the G state, so if you take option 1, if you take one action and you 100% reach to state A. There is no other possibility that you reach to state B or any other state. You are deterministic about your upcoming state, that is going to be A. And if you take action 2, action 3, action 4, 5, 6 and you reach your desired state, that is the deterministic where you are 100% sure about the upcoming state which is going to happen. So in Markov decision process, uncertainty in the real world means you are not sure about your upcoming state. You are on the state, you take action and you don't know which will be my ending state. Either you end up as 1 prime or as 2 prime, you are not sure about. That's totally depend on probabilistically. So we are also called as stochastic. So stochastic is for each state and action we specify a probability distribution of our next state. Like if you are on state as state and you take an action and you probabilistically describe that there are 0.7% chances I can end up as 1 prime state or 0.3% chances I can end on as 2 prime. You are not sure about that upcoming state. Okay, that is the Markov decision process. So here Markov decision process use how he take decisions that which path I should follow to reach my goal. So past independent agent. So agent is one who is taking action. So the future is independent of the past given the present. So the agent has no concern with the past data. Agent is like a new and he just work on probabilistically that I have 0.7% chances on this state that this if I take this action, I will reach to my goal. There are 0.7% chances and 0.3% chances that if I follow this path, I will end up in that very state which is my goal.
Yeah, so you mean to say that the chances you will decide at the moment.
Yes, at the moment, agent decide that which action I should take.
But agent will have some knowledge because educated guess is something else and blind guess is something else. Okay.
Agent will decide on the basis of probability.
Okay. Probability is, see, if we are tossing the coin,
Yes,
there
sir.
is a one head and another tail.
Tail.
Okay. So in this situation, what will you say? This is yes.
0.05 chances that I gonna come up with head or tail. 0.
So this is the rational thing that 50-50 chance.
50-50 chance.
You are getting head or you are getting tail.
Yeah.
The probability. But you said that agent will have some knowledge 0.7. Yes.
Sir.
So I would like yes question. There is a question, please.
How will the agent know that the probability gonna be 0.7 or 0.5?
Yes, sir, the next.
We should have a pre-knowledge that I'm gonna face
He will
traffic.
try to explain.
That on-
Allow him to explain. Yes, please.
So-
Good question. Yes.
So agent has nothing to do with the past data. So how he knows that there are 0.7% probability there? So next line, that state captures all the relevant information from the from the history. State captures that there are 0.7% chances if you follow my path, you will go to your destiny, you will go to your path. Agent just take an action on the basis of probability.
You told me that it had nothing to do with past, but it's again making probability on the basis of the past things,
Yes.
right?
The state,
It
only
needs
state,
pa- it
agent
needs
is
past data to make a
Yeah,
probability.
actually, I think we should need to learn about the state because agent does not know. Okay.
Yes, sir.
He is talking about states. Let's know your question, please.
So you are explaining Markov finding. So is it an informed algorithm or uninformed?
Uninformed.
Algorithm?
That's the question.
Yeah.
it's totally uninformed.
Okay,
Because
let's-
things
So
that
it's a
are-
brute force.
Explain. And you're clapping for Umar, okay? Yes.
Because things are gonna happen
Uncertain.
unrealistically.
Yes.
Means there are probability chances. So you are not sure about your upcoming state or outcome. So I have I come up with an example so you will get very clear knowledge. So the example is that for each round R is equal to 1 and 2, 3, 4, 5, 6. So you choose, okay, now let me explain. You have two states.
Yes, these are important. Please.
You have two states, in state and end state. The in state where you are currently standing and the end state where you want to reach. So if you quit, you get $10 and we end the game. If you stay, you get $4 and I roll a 6 dice. If dice result 1 or 2, we end the game. Otherwise, we continue the game. So let me explain over here.
So it work on cost.
So this is the state where we are currently standing, and this is the state where we want to add up. So we have in this example that in the in state we have two options. That option is deterministic. Why deterministic mean in end you choose yes, then you come up with another state, and if you choose no, you're gonna be end the game. Okay, that is because you know that if I choose no, I will reach to my end state, and if you yes, then you come up with another state that I will describe in later. So if you choose no, you will get $10 and the game will gonna be end. Okay, so these two states are chance node. I call it chance node because they tell us that you start from in state and decided to end the game, which is yes. And it tells us that you start from in state and decided no, that I gonna quit the game. So it's clear that if we decide no, then we quit the game and get $10. Okay. But if we decide yes, that we want to play the game, then in that chance mode we roll a dice. Okay, we roll a dice, 6 dice. So if we get 1 or 2,
1/6.
1 or 2, or else if we get other than 1 or 2, so there are probability
1/3. 2/6 is 2/3. 1/3. Plus 1/6.
2/3.
No, actually slides are finished.
So there are no ifs of probability that in this chance mode we roll a dice, and if dice gets 1 or 2, we will go back to our instead, and if dice get other than 1 or 2, we are gonna be end the game. So there is this probability, that 1/3 probability that we go back to instead, and again we decide what we gonna do. And if we get other than 1 or 2, that's the probability is 2/3, which tell us that now we end the game and get $4.
Yeah, you mean to say that, okay, actually, it's including me, we want to learn, okay, many students are sitting here, and this is a very crucial topic. So, about the states, in this situation, someone will start his journey
From
and-
instead.
in point, and to the end, but there are some situation, if he will not start, then he will get a $10.
And quit.
Of course, good case, will not start. But in case of start, if there is a dice roll, 2 possibilities, 1
Yeah.
or 2, okay, out of the 6 possibilities.
Yes.
So this is look like 0.33, yeah, 0.3.
0.33.
And if you will consider the other 4 options, okay,
0.7.
out of the 6, it is look like 0.7. So you said that these 2 states.
These two, 1 and these two states. These are not states.
Come on, I mean to say 0.3 and 0.7, 2 things. Are
Yes.
there. 0.3 and 0.7 are the states here.
No, these are not the states. These are the chances. Let me explain. So if you decide yes, and you come up with this chance from which tell us you start from in and you decided yes.
Yeah,
Now
and
this
it's
chance from where the
just-
magical things are gonna be happen. How? These are the state where you don't know what gonna be my next step. So that is the Markov decision where you don't know about the upcoming step. Now there is a probability distribution that there is 1.3% probability that you again go to instead, and there is 2.3% probability that you go to end state. So this chance mode actually it's a Markov decision where you don't know about the upcoming state. So that is the thing where you are not sure about where you going. By dicing the roll, you will know where will go. So that is the Markov decision where you don't know about the upcoming, like this state, where you don't know about what is going to
Proceed
happen.
to the next of your slides. Finish?
No, I have some.
Okay, go back. Yes, please, there is a question. Then listen then.
But if we roll the dice, it's upon the dice, there is no decision. If the dice comes, then it will take decision. How can Markov decision gonna work when there is no roll? When you have not rolled the dice before, what is the decision before?
Yeah, before the decision, we don't know. Actually, this is not Markov. This is the example that what is actually Markov decision, how you don't know about the upcoming. Like at this state, you are not sure about that. I will go to in.
We are not sure about the outcome, but we are sure
about the probability that there is 1/3% probability you go again to
Of
n.
course, many questions will raise, but you should proceed to the next page. Of course, maybe some of us will get the clue. Yes, you want to say?
So this is a Markov decision process where you have set of states and set of actions, and you get real value default function. Means you have set of states. Set of states that state 1, state 2, state 3, state 4, and that is your end state where you want to go, and in between you may have faced many states, and set of actions that you have this actions, and set of actions that at this stage you have this action, and you also have this action. Also, like you have many actions at a particular state, and after every action you get reward. either reward is positive or negative. That's come in reinforcement learning, but I have not touched this in topic because you may get confused. So policy. So that is, what is the policy? So policy is that which path you follow to reach your destination. So that is the policy. Like we have 1 state, 2, 3, 4, 5, 6, and which policy I follow to reach my destiny. So that is the following path is called policy. So that is it. That you take an action. You another come up with another state. You come up with another state, and again you are not sure that about. You are not sure that if I take action from this step, what is gonna be my next step? So again, this thing happening in Markov decision process.
Close it and start again. Just double tap.
I have another example.
Okay, we should start. Go.
So let's take a real life example. What if you are here in university and you want, that is your starting step, and you want to go home, that is your ending state, desired state where you want to go, and you have 3 possible options available which you follow and you reach to your destiny, which is home. So option 1, maybe you use bike to go your home, maybe you use car or some anything else to go, or you use train to go home.
Okay.
So now there's another thing. So if you choose to decide bike, you're gonna reach to your home in 45 minutes. But if you choose car, you will go to your home in 30 minutes. And what if you choose train? You will round about 35 minutes. If we say you will end up with 35 minutes. So again, so if you choose bike, this is deterministic that you go to you cover 45 minutes and you go to home. So in that case, this is deterministic state that 45 minutes will surely be taken if you choose this bike. So what if you choose this bike? You will take 30 minutes, and in that sense you may, if you choose car, you may get traffic. So there are 3 states of traffic. The one state is medium traffic, the other one is very heavy traffic, and very low traffic. Okay. So if you choose car, there are 0.3% chances probability that we face a very low traffic. So there are 0.5% chances that we face heavy traffic. So there and 0.2% chances that we may face medium traffic. So in that case, again you distribute your time. So in that sense, if you take if you get low traffic, you will reach your destiny, which is 30 minutes. If you're stuck in heavy traffic, you may consume your time to increase to 45 minutes or maybe some other. And if you face medium traffic, you will reach to your destiny, which is, we say for example 35 minutes. So there is your second choice if you take car. So another, if you choose train to reach your home, there's also that kind of thing happening. That sometimes train you have to wait for the train, and maybe you wait, and there is, for example, this 0.3% chances that you wait for train, and 0.7% chances that you get train. So in that sense, if you have to wait for 0.3% you wait and you reach your time, you may consume your only 30 minutes.
35.
Only 30 minutes to reach, and if you get directly train and you reach 35 minutes.
Okay, and this tells us what? If we are following the motorbike, we will deterministically
Deterministically reach. So if we follow car, That is not deterministic. That is uncertainty in the decision of path that we face traffic, heavy traffic, low
Go
traffic,
to the next slide. Yes, we get this.
and that can affect our decision. That can affect
Yes.
our time. So best our
Yes,
time.
good. Yes, please.
So application, so Markov decision process comes under many application where, so if we take an application of robotics, so how it Markov decision work in robotics. For example, if you have a robot and you want from robot to do a task for me or to pick an object for me, and you start, you just tell to the robot and to pick the object, but in between there may be the actuator in the robot gets failed, or maybe some other problem faced that you
being an agent, you are giving a command, but actuator can fail.
actuator can fail. That
Yes.
is the uncertainty, and some other factor can occur in between which you don't notice while you're making decision. So that also come in resource allocation. So in resource allocation, for example, you want to produce a product, and that product should be success rate should be depend on the customer. That what is the customer need and what you are capable of making. So that all require resource allocation, and you have a model that are not 100% accurate to predict that you should go for that problem. So because there are a lot of uncertainty, so Markov decision process also helps there. And in agriculture also, you are not sure about the whether that it is whether suitable for my crop, or crop gonna be yield over there or not. So these type of problems we are not thinking while making decision, but they lead to make a big problem. So to tackle these problems, we come up with Markov decision process. So Markov decision process, we can easily solve our problems.
Okay, well done, very well done. Before starting the question, I have little, okay, if you allow me to speak out. For example, I want to get some job,
Yes.
okay, or maybe to get admission in particular university. There are two possibilities. One is on the basis of score, okay, if I am getting very good score in the intermediate, okay, only on the basis of score. Another situation, if I do not have a good intermediate score, then I need to, the deterministic is I must have a very good score in the
Yes,
intermediate.
deterministic.
Other one, if I do not get a very good score in intermediate, okay, then I need to pass the
Entrance exam.
entrance exam with very good score.
Yes.
Then I also need to appear, okay, in some interview I need to pass the interview gracefully. So these are the
Unreal and uncertainty that
uncertainty.
So-
But my question is, deterministic, then don't need no problem.
no problem.
No problem.
Yes.
But once there is no deterministic approach, then you need to apply the Markov decision, and it depends upon the states.
Yes.
For example, of course, it also depends upon the how much marks I will get in the entrance exam, or
Yes.
how much marks I will get the ratio of the probability whatsoever. Then even this will uncertain if the final entrance you can say that the merit, many intelligent students will
Yes.
opt for the test, so of course I will not be selected. Is it okay?
Yes.
Like this?
Like this is that where you're not sure about that if I get top score in entrance exam, but still you are not sure you get admission or
Yeah,
not.
where merit so super
So
duper
high,
high.
yeah.
Yeah.
Then may become.
So deterministic, if, please try to understand. First of all, system should be deterministic. But in actual, many times, we cannot maintain the deterministic system. For example, in case of a robot, we cannot make the ideal robot which
Yes,
can
I
work
agree.
in all the situations. Because sometimes robot can face the unknown situation.
Yes.
In this situation, of course, Markov decision model will be applied.
Yes.
Are you getting my point?
Yes.
If we pass the intermediate exam with very good score, then it's a very deterministic thing that we can get admission in a very good university somewhere. But in case due to certain accident or certain mishap or certain medical reason I could not get it, then Markov decision model will apply. Yes, please.
Sir, it will make decisions on the basis of probability.
Yeah, probability that, of course, there are the states will be involved. States will be involved, for example, how much I am smart, how much I can get a good interest or a good score in the entrance exam. This is not one thing. Okay, so states, if I am getting very good score in the entrance exam, then the ratio will be high. Okay, if I am not good in the good score in the intermediate as well as not good score in the entrance exam, then what will happen? Then the probability is this: merit should be very low. Are you getting the point?
Yes.
This is the situation. Anyone else want to ask a question from? No? Clap for Umar. Very well done.